I'm back with another session on the section of solids. Yesterday we studied about the different type of cutting planes that are there in the cutting of the solids, and those cutting planes are named as AIP, AVP, HSP, VSP, and these cutting planes are then used with the help of the cutting plane line, which is the representation of a cutting plane as given in the picture here, that this cutting plane is an AIP and it is shown with the help of a cutting line, which is the vertical trace of the cutting plane. So over here today I'll explain you the difference between two type of solids which are generated by using the cutting planes. First kind is the frustum of a solid, and the second kind is the truncated solid. Generally, when the solid is resting on its base, over here we have an example cone. This cone is resting on its base on the ground. So this ground is taken as HP, horizontal plane. Base on the ground for this solid cone is also taken as on horizontal plane. Base on ground, it means the ground is assumed as the horizontal plane. So in this pictorial view, you have a cone, and this cone, as it is being cut by an HSP. Now if you remember, what is HSP? HSP is horizontal section plane, and the cutting plane has its surface perpendicular to vertical plane. So it means if I am writing V and T, it is making a vertical trace on the vertical plane. So if this is the line, this is passing through a solid, it means this line is the representation that it is cutting the solid parallel to the base of the solid, and if it is cutting parallel to the base, the result is a frustum. So frustum has a section, a section is generated on the cone which is actually parallel to the base of the solid. Condition should be that base should be resting on the ground, or the base should be resting on the horizontal plane, which is HP. VT. So this VT is the representation of horizontal section plane. Now if we look at the second case, in the second case it is a truncated solid. So how this truncated solid is generated? This is the picture of a truncated solid. How is this solid generated? When I have a cutting plane which is AIP. Now why I am using AIP? Because this cutting plane is now inclined to the base of the solid. So the common condition should be the orientation of the cutting plane with respect to the base of solid. If I am taking the base of solid in every one of them to be on the horizontal plane, I am taking into account a plane which has its surface, cutting plane which has its surface parallel to the base, creating a frustum of the solid. I have a cutting plane AIP which is inclined to the horizontal plane, and it is generating a truncated solid. On the other side, if I assume that the base of the solid was towards the vertical plane, if the base of the solid would have been resting on the vertical plane, so by which method I would generate the frustum of the solid? How? I will generate the frustum of the solid by using a vertical section plane. Why? Because then the cutting plane would be, the surface of the cutting plane will be parallel to the vertical plane, and if it is parallel to the vertical plane, it will cut the solid parallel to the base which is resting on the vertical plane in that case. Alright, so in this case we are showing the solid to be resting on the ground on its base, and we are taking a horizontal section plane. It is creating a frustum of the solid like this, and second, it is generating a truncated solid if the base is on the ground or it is on HP, and it is generating a truncated solid like this in the picture. So over here AIP, and AIP is auxiliary inclined plane. Auxiliary means it has its surface inclined to any one principal plane, which is HP, because in AVP the cutting surface is inclined to the vertical plane. So AIP has its cutting surface inclined to the vertical plane, and this plane is also shown by marking V and T. It's also making the vertical trace on the vertical plane. Why it's making vertical trace on the vertical plane? The reason is the surface of this cutting plane is perpendicular to the vertical plane. Over here also the surface of the cutting plane is perpendicular to the vertical plane. So in this case also it is perpendicular to the vertical plane, in this case also it is perpendicular to the vertical plane. So for both the cases it is creating or making a vertical trace on the vertical plane. The difference is it has its surface parallel to HP, it has its surface, cutting surface, inclined to the horizontal plane. I hope you understand this, and I am making another example for frustum and truncated solid. If we are assuming the base of the solid to be on the vertical plane, and over here truncated result to be on the vertical plane. Let's see how they look. So over here in the example, as you can see, I have taken another solid cone, and if you can see from the top view, this cone is resting along its base. This cone is resting along its base on the vertical plane. So these two planes are the representation of the principal planes. This is HP, this is vertical plane. This cone has its base on VP, or it has its base towards the vertical plane. So I've taken a cutting plane which is parallel to the vertical plane, perpendicular to the horizontal plane, and this type of cutting plane is represented by making a HT. HT is the horizontal trace which is on the horizontal plane, because it has its surface, cutting surface, perpendicular to HP. So now this type of solid which is generated after the sectioning, this is the frustum of the cone. Likewise, we can also draw the truncated cone which will have its base towards the vertical plane, or will have its base resting on VP. So we'll take a cutting plane which will be inclined to the base of the cone to represent a truncated solid. Students, for more clarification on the subject where we have to use the cutting planes, the projections of the solid will be made on the principal planes, and if the projection is a front view, it is made on the vertical plane, and if the projection is the top view, it is made on the horizontal planes, right? So there are different type of sections which are generated after the solid is cut by the cutting plane. Now we have named 4 types of cutting planes here. So which cutting plane is responsible to create what type of section? You need to understand this. If you are using a cutting plane which is HSP or a VSP, Now these two cutting planes, what do they have in common? The surface of the cutting plane is parallel to HP if it is an HSP. The surface of the cutting plane is parallel to VP if it is a VSP. So the cutting planes, if it is an HSP or it is an VSP, true section will be generated on the solid. The solid which is cut by an HSP or VSP will create a true section on the solid, whereas the cutting plane, if it is AIP, auxiliary inclined plane, or it is AVP, auxiliary vertical plane, means if the cutting plane is inclined to the solid base or it is inclined to the vertical plane like here in AVP, or if it is inclined to the base of the solid, if the base of the solid is resting on HP and it is an AIP plane which is actually inclined to the horizontal plane, so the section which is generated by these two category of the cutting planes is an apparent section. In the syllabus and in solving the questions on engineering drawing, in making the drawings, you will be asked to make the sectional front view and sectional top view if the cutting plane is an HSP or it is an VSP, whereas in the questions where the cutting plane is a AIP, is an AIP, or if it is an AVP, you will be asked to generate or project three views, which it will be a front view, it will be a top view, and it will be another view where you will show the true section of the solid, plus you will have to show the apparent section of the solid. Means the top view in this case where we are using the AIP and AVP, the top view is an apparent section, whereas in HSP and VSP the top view or front view, in this case also the top view or the front view will be an apparent section and the top view or the front view will be a true section. But how come one more view that is you have to show in this part? Just because if any of the view is an apparent section, is it a front view or if it is a top view, then an extra projection is to be drawn in this case, which will be to show the true shape of the sectioned part, true shape of the sectioned part. Now I will clarify you this, how apparent section is being made in case when if it is an AIP or AVP, and how if it is an HSP or VSP the true sections are being generated. I'll clarify you in the next drawing. So let's do it. Let's begin. Let's see how the cutting planes work here. So I've taken an example of a horizontal section plane that you can now clearly guess which one of the drawings is a horizontal section plane, and I've taken a auxiliary inclined plane that you can also guess which one of the drawings is using a auxiliary inclined plane. So in both of these drawings there is one common thing between the cutting planes. They are generating the vertical traces. They are generating the vertical trace. This vertical trace is generated because, I'm repeating it again, because the surface of the cutting plane is perpendicular to the vertical plane. The surface of the cutting plane is perpendicular to the vertical plane. So vertical trace is generated. So this type of cutting plane will be represented by its vertical trace. This type of cutting plane is also represented by its vertical trace. Moving forward, the first drawing here, I'm pointing towards the first drawing. It is using any guesses? It is using a horizontal section plane, and in the second drawing it is using an auxiliary inclined plane. Now you can see the cutting plane is passing just right in the middle of the solid. The solid is a cone. You should all be knowing that it is the projection of a cone which has its base parallel to the horizontal plane. It is actually not resting on the xy line. It means the base is not on HP. The base is only parallel to the horizontal plane. So we have made the projections of the cone in the front view and in the top view, and over here we have used a cutting plane which is an HSP plane, and it is being represented here with the help of the convention of the cutting plane line, which is VT, and this plane is an HSP. In the second drawing we have used the same solid, which is a cone, which has its base parallel to horizontal plane. The base has not come on the reference line, means the base is not resting on HP. It is above HP. It is parallel to HP. So we have projected its front view and its top view. Now, what is the similarity in the drawing? The similarity in the drawing is both the bases are circular in shape. Why they are circular in shape? Because if the base of the solid is parallel to or it is on HP, the true shape of the base of the solid, in case of the cone, the shape of the base is a circle. The true shape of the base of the solid, the actual shape which becomes the true shape, is projected on the horizontal plane in the top view. We are doing these questions in the first quadrant, in the first angle of projections. So the top view is a circle. So the top view is a circle in both the cases. But in both the cases we have taken different cutting planes. In the first case it is an HSP. In the second case it is an AIP. Now over here, the cutting plane line, which passes somewhat through the middle of the axis of the solid, axis of the cone, is cutting the solid right away like this. We are cutting the solid right away like this, parallel to HP, and so that this part over here, it is written, this part is removed. This part of the solid is removed. When this part of the solid is removed, it looks like this. This much of the part which is shown in the small circle, this is being removed. When this is removed, when you will see this from the top view over here, the top view will change. You will be able to see the base of the solid, and a section in the form of a circle will be generated in the top view. Likewise for the second part, when you are using a cutting plane like this, an AIP, which is making an angle with the HP, you are removing this part, and the shape of this part is like, which is shown in the small circle, it is like this. This part is being removed, and the remaining section, and the remaining the surface or the section which is generated on the solid will be seen in the top view. When you will see from the top side of the solid, you can see the section over here in the top view. For this you can see the section here. For this also you can see the section in the top view, right? So remember, when you are using a HSP and an auxiliary inclined plane, the sections are always generated in the top views. For the first angle projections, when you are using an HSP, when you are using an AVP, the sections will always be generated in their top views. In this explanation, I have only explained you of the cutting planes, how to use them, but I have not actually projected the section views. So the section views will be projected in the next step. So moving towards the next step, let's see how the sections work. So wherever the cutting plane line has passed through the solid along the axis or along the generator or along the boundary of the solid, it keeps on cutting the boundary as well as the inner generators of the solid. So these lines which are marked with red are the generators of the solid. In actual drawing, only the lines which are green in color, these are the visible boundary lines, and the lines which are red in color, they are the light lines. They are actually the generators of the cone. So when a cutting line passes through the solid, it keeps on intersecting with the various lines which are there in the drawing. So wherever it passes through, it tries to cut those surfaces of the solid, means that it is actually cutting the solid portion of the solid portion of the solid. So we have shown the boundary of the cone in the front view as A dash, O dash and E dash, and the cutting points which we have obtained, they are mentioned like this. So these are the cutting points. One encircled one is marked here, is on the generator A dash O dash, which is the boundary of the cone. 2, which is in a circle, inside a circle, is on H dash O dash B dash O dash. You can see in the front view, you have to study the front view first. Wherever the cutting line passes, in whichever view it passes through, you have to study that view first. So 2, second is the cutting point, second circled cutting point is on the generator H dash O dash and B dash O dash. You can see it very clearly that I have marked here H dash B dash O dash. O dash is the apex of the cone. So the second cutting point is on H dash B dash and O dash. You can say it like H dash O dash B dash O dash, because two generators would be in the same plane. One generator H dash O dash, and behind it the other generator will be B dash O dash. 3, the third cutting point is here, right away coming on the axis of the solid, as well as the generators G dash and C dash, G dash, C dash, O dash. So the third point is on G dash O dash and C dash O dash. Likewise, the axis of the solid passes through the center of the cone, and both the generators are coming in one same line along with the axis of the solid. Next cutting point 4 is on the generator F dash O dash, F dash O dash. Here is the point number 4. It's very small. I hope it's visible to you. And D dash O dash, D dash O dash. Right, you can see here in the front view F dash D dash, the generator number 4, it's coming here. The cutting point number 4, it's coming on the generator F dash O dash and D dash O dash. And 5 is on E dash O dash, E dash O dash, the last cutting point 5. So we have 5 cutting points by the cutting plane line. which is a representation of a cutting plane, which is horizontal section plane. Likewise, for the second question, I have kept the notations same in the top view and the front view, and same cutting points are thus there in the second part. But over here the cutting plane is an auxiliary inclined plane. Now let's look at the results. Whatever section we get in the top view, will it be a true section? Like here I have said, the section generated is a true section. Over here, whatever section will be generated, will be made or projected, will be a true section. Over here, whatever section is generated in the top view will be an apparent section. How? This was the question which was raised on how it is a true section, how it is an apparent section. An apparent section is a section which is generated when it is an AIP. A true section is generated when it is a HSP or VSP, AIP or AVP, HSP or VSP, and the orientations or the cases may differ for different subjects, right? So let's see what is the shape of this section which is generated in the second part and in the first part. Now in the next step, I'll be removing this portion, so you will not be able to see any more of this portion, but you'll definitely able to see the cutting points and the cutting points here, and I'll remove this part, and whatever part is removed is thus shown in the actual drawing by continuous light lines. Means I'll be making all of these lines which were in green or red, all of these lines with one color, and I'm using the red color for continuous thin line. So I'll be making all these lines with red sketch pen. Now let's see how the section is generated. As you can see now that these are the cutting points 1 2 3 4 5. You can clearly study and go through the cutting points and the lines which were dark earlier and were marked by the green lines, a green pen. So all of those lines which were dark, they are now light lines, and the red lines are now telling you that this portion has been removed by the cutting planes. VT is the cutting plane 9, and in the first part we are using HSP, and in the second part we are using AIP. Now let's proceed towards how the cutting points help us to obtain the sections. The how cutting plane will help us in the first part to get us the true section, and how cutting plane in the second part will help us to generate an apparent section. Let's do the exercise. So what I'll be doing is I'll be showing you will have to drop the projections in the form of straight lines from all the cutting points named as 1 2 3 4 5 onto the horizontal plane. And in the top view you can see the circle. In the top view you can see the circle for both of the drawings. So you will have to take the projections in the form of straight lines, straight vertical lines, and drop them onto the generators that you can see in the top view. Like for example, from cutting point 1, we'll drop the first line on the generator AO in the top view like this. So now you can see in the drawing that from cutting point 1 I have taken a straight line, and the view you can see in the top view. So I've taken the projection from cutting point number 1 and have straight away dropped it to the generator AO in the top view, and wherever the line has stopped, the blue color line, wherever it has stopped on the straight line AO is the projection of the generator in the top view. at that point is the cutting point 1. In the similar way, we'll take all the straight line projections from cutting point 2, 3, 4 and 5 and we'll drop those projections on the generators. So like this, what I was telling you, that from this cutting point 1 I've dropped a projection onto the generator AO in the top view. Likewise, from the cutting point 2, from the cutting point 3, from cutting point 4, 5, we'll drop the straight line projection starting from this point to the respective generators in the top view. Like for example, I have to start from cutting point 2. I'll start a straight line from this point. I'll take it straight down and I'll take it till BO in the top view, generator BO in the top view and generator HO in the top view. Likewise, for point number 3, when I'm dropping it, I don't receive any of the intersections in the top view. So to obtain the cutting point 3 in the top view, you will just have to take this point into account, where the dropping of 2 intersects with the generator BO in the top view. You will take the same radial distance by keeping your compass pin on point O and point 2 in the top view and drawing a radial intersection with the generator CO and GO for this point 3 to be in the top view. Likewise, when we will have all the cutting points from 1 to 5 in the top view, we'll join all those cutting points with the free hand. I'll show you in the example how we are doing it from 2, 3, 4, 5. Likewise, in this example also, I've shown that from cutting point 1 we are dropping the straight line projection onto the generator AO. Same all the points are same for example 1 and for example 2. All the cutting points have been obtained in the top view, and see, so we have dropped the projections from cutting point 2 straightway on the generator BO in the top view and HO in the top view. So wherever this straight line is cutting the generators in the top view, we are marking the points in the step 2 on both the sides. For 3, we have taken the radial distance, because if we drop a projection from 3, it doesn't cut anywhere on the generator, it just passes through the straight line. But if we take the radial distance, why taking the radial distance? Because the cuts obtained on the generator, because if the plane is cutting the solid parallel to its base, all the generators and the cuts obtained will be at all the cuts on the generators that are obtained will be at equal distance. So we have taken the radial distance from this point O apex and till the point 2, which is obtained on the generator BO and HO. So you have just rotated it about the generator CO and GO, and we have got the point number 3 in the top view. Next, for point number 4, a simple straight line on the generators which are in the top view DO and FO. We have got the point number 4, cutting point 4. And for last point, the blue line, the dropped on the generator E-O'. You can clearly see that 5 is lying on E-O' in the front view. The notes that we have made it, 5 is on E-O'. So same way, Now by using a straight line, we have got the cutting point number 5 in the top view on the EO. Now the last step is to join all of these points together and obtain a section. The section which is obtained by joining all of these points together will be a true section. To note here, all the lines that you see in green, these are the dark lines, and all the lines that you see in red and blue, these are the light lines. Just remember that conventioning is very important in engineering drawing. So all the lines which I have made with green pen, they are the dark lines, and all the lines that I have made with the red marker or blue marker or pen, they are all, the lines are light lines. So you have to practice it, that all lines shown, all light lines to be shown in the drawing will be of the same consistency and strength. All light lines should look same and all dark lines should look same. There should be no difference in the appearance of the line in the drawing, because if that appears, so third line will enter the drawing, and that is not acceptable by any of the examiners or any evaluator who's looking after the drawing. Okay, so let's look in the next step how the shape of the section has turned out. So now I have clearly joined the points together, and I've got a elliptical shape here, but in actual it is not elliptical, it could be a circular shape also. And this is the shape of the section that I have got in the top view when I remove this part and I have used a section cutting plane which is an HSP. Now you will be able to see two dark boundaries. The outer circle is the base of the cone, and the points marked with 1 2 3 4 5, these are the cutting points, and this has created a circular or elliptical section on the cone. So the two boundaries are dark, the apex is removed in the top. Over here we can clearly see the apex is removed, and now this part of the section will be shown by sectioned or the hatching lines, section lines. So you will have to use a light pencil, that is 2H or 3H pencil, to make the hatching lines, and the hatching lines will be inclined at angle 45 degree, with the spacing between each line should be around 2 mm to 3 mm. The lines should be uniform and they should look good in the section. So you have to produce a uniformity in the section, producing by creating the section or the hatching lines to show that this surface is actually the sectioned part of the solid. I'm not just focusing on the section which is created, so you can now see clearly that this is the section part which is created, and I have drawn the section lines or the hatching lines. The angle should be 45 degree to the user, and this is how all the cutting planes and sections are created in the engineering drawing. I hope you have understood about this question, and moving on to the second part, I'll show you how the section is created if we use an AIP, and what is the difference in the appearance of the true section and an apparent section. So I have completed the cutting lines. I've taken all the cutting lines on the horizontal plane. You can see in both the drawings that there is no visible difference between the true section which is generated and the apparent section which is generated, because in the second drawing I have also used the same method as in the first case. Like for the point 3, if you move the projection line, if you take the cutting plane line on the horizontal plane, you will not be able to get any intersection cutting point on the generators, rather it goes just through the line. So to create a point on the generator CO and GO in the top view, you will have to radially move the point number 2 by taking the distance from apex point O till 2 and radially move on the generator CO and GO. By doing this, you will get the point 3 in the top view, and thus you will be able to get all the cutting points in the top view. By joining them, you will get the section. A section is generated. So the outer points, the outer circle is the base of the solid, which is circular in shape of the cone ABCDEFGH, and all the cutting points 1 2 3 4 5, they have generated a section on the surface of the cone, on the top portion of the cone. This is actually the look of the frustum cone, and this is the look of a truncated cone. So you can see there is no visible difference between the section which is generated by an HSP and the section in the top view which is generated by an AIP. This is why these sections are called as the true sections, and this section is called as the apparent section. This is why both the sections which are created in the cone, these are called by different names. So this is the true section. A true section we get when the plane is parallel to HP, and an apparent section is not the true section, is not the actual shape of the section. This is AIP, and thus this is not the true section, this is the apparent section. This is not the real or the true shape of the section, but this is the real and the true shape of the section which is generated here. To find out the true shape, we need to follow a procedure, and thus in these type of questions where you have a cutting plane such as AIP or AVP, you will have to draw 3 views. First will be the front view, the sectional front view. Second will be the sectional top view, and third view will be the true shape of the section. So over here, the objective question could arise if we are using an HSP or VSP. Would you get a true section or an apparent section? True and false. If we are using an AIP or AVP, would you get a true section in the top view? True or false? It's false. We get an apparent section in the top view. If you're using an HSP, you get a true section in the top view. If you're using an HSP on the solid, would you get an apparent section in the top view? False. We get a true section in the top view. If you are using an AIP, would you get a true section in the top view? No, we get an apparent section. So such type of objective questions can be composed out of these answers, and thus I hope you understand about the sections which have been generated on both of these questions. So looking further, I have to just clear you about that there is no visible difference in the section. The section generated in the first part is called as the true section, and the section generated in the second part is in the top view. This is called as the apparent section. To make the true shape of the section, how does it look? You have to further follow the steps to actually find out the shape of the section. The shape of the section is not circular or elliptical. The shape of the section could be something different that you will be able to find out through the further steps. I hope you understand today's lecture, and if you have any doubts in the today's class, you are free to comment in the comment box. Leave your comments, leave your questions, leave your queries. I'll be happy to answer them, and in the tomorrow's class we'll be going to solve the questions from the assignments or from the books which are provided to you or which you have. If it is clear in the today's class, just go through the lectures very carefully. Try to understand each point and objective of using the cutting planes, and listen them very carefully, so be able to understand and attempt the questions correctly. Thank you for watching.